Active transport is the form of transport of materials into or outside the cell involving expenditure of energy. Involving expenditure of energy. However, this active transport is divided into two categories. There's what we call primary active transport Now, under primary active transport, here is ATP expended directly. As the material is being transported, there is direct expenditure of ATP. Now, there is also what we call secondary active transport. Secondary active transport. Here, indirect expenditure of ATP. That one is very important to understand. So I've got primary active transport and secondary active transport. Now let us use a luminous cell of your intestines. So here we have the luminal surface. Luminal, you can also call it, so you can call it luminal or apical membrane, the one lining the opening of the lumen of the intestine. Then we have got the basolateral membrane. So what we have this way is the intestinal lumen. What we have this way, we shall have blood. Okay. Now let's look at this point here. We are beginning with the basolateral membrane of the luminous cell. We want to see both types of active transport being demonstrated here. Now, there is a protein here, which is the sodium potassium ATPase, but also feel free to call it sodium potassium pump. This protein here pumps 3 sodiums to the outside and brings 2 potassium to the inside. But that process involves expenditure of ATP. The process involves expenditure of ATP. ATP is expended. Why? Naturally, there are more potassium ions inside the cytoplasm of cells than outside. And there are more sodium ions outside the cells than inside. Meaning, when you take 3 sodiums to the outside of this cell here, you have to apply energy because you are taking it against its concentration gradient. Likewise, potassium ion. So ATP in this case is expended and hydrolyzed into ADP plus an inorganic phosphate. That's very important to understand. But now look, as the sodium ions are taken outside by expenditure of energy, it means sodium ions are increasingly made less inside here. Their molar concentration inside the cell here, in the cytoplasm of this luminous cell here, is greatly reduced. But those ones of potassium, that one of potassium is increased greatly, but sodium drops down. Now what happens? The sodium in your food, because when you eat food, we add sodium chloride there. Okay? Now this sodium, we don't know. Little do people know, do most of the people know, that besides improving the taste of food, it is also having a transport value. Reaching the lumino whatever, there is a protein here. This protein here is a symporter. Is a symporter. By symporter, I mean it transports two chemical species in the same direction. It's a symporter. So this protein here, as sodium concentration greatly decreases here, by pumping sodium outside here, sodium here is going to diffuse from the components of the intestine here to enter the intestinal, the luminal cell by diffusion. Now, its energy, because the diffusion, the rate at which it is entering now is increasing. Why? There is a void created inside here because potassium, sodium is being pumped outside. It means there is energy due to diffusion. As it is diffusing, there is energy, there is a force here created now. Now, the energy of sodium to enter is coupled with the entry of glucose. So glucose takes the advantage of the diffusion of sodium to the inside of the cell, such that glucose also follows suit. Now look, in this scenario here, sodium ions on this side here and the potassium ions are transported by primary active transport. Now, this sodium enters also by diffusion, but now the energy due to its diffusion, it is utilized by this glucose also to enter using that same symporter. So meaning glucose here is transported to the inside of the cell by secondary active transport. This kind of transport, it is the same transport utilized on other monosaccharides, but also it is utilized on absorption of amino acids in the gut, but also it is utilized by the kidney nephrons during the counter-current exchange mechanisms, which we shall be discussing in the future. So this transport here is the one which is being utilized. So these ions are transported by active transport. This one here, this glucose is transported by secondary active transport. Those are the two types of transports, or the two categories of transports: primary active transport and secondary active transport. Now, I know this is the last episode I've discussed about these kinds of transport, but some people may be asking themselves, why hasn't he discussed the bulk transport like endocytosis, pinocytosis, phagocytosis? Why? The answer is simple. Those ones are not categories of transport across a plasma membrane. They are not. They are not types of transportation across a plasma membrane. That one should be noted very well. Thank you very much for listening in and watching. May God bless you.